Dear friends, welcome to our channel once again. Today, we are going to discuss how to revolutionize sensor technology. First, a brief outline of the present status of sensor innovation. Sensor innovation has turned into a fundamental piece of our day. Today, routines, assuming an essential part in various ventures like medical services, car, natural observing, and that is just the beginning. Nonetheless, the persistent quest for development is vital for addressing existing difficulties and fulfilling the advancing needs of a quickly progressing mechanical time. The significance of sensors in different enterprises. Sensors act as the eyes and ears of current innovation, empowering gadgets and frameworks to see and answer their current circumstance. In medical care, sensors screen fundamental signs and work with innovative diagnostics. The car business depends on sensors for security highlights and the improvement of independent vehicles. Ecological sensors add to how we might interpret environmental change and contamination. In natural calamities, can work hands and gloves with artificial intelligence to manage the crises. The use of sensors has been amply covered in my previous vlog and an article. In my blog, under the heading of Use of Artificial Intelligence in Natural Disasters, links for both are given in the description below. Arising demands in various enterprises. The advancing scene of ventures presents new and dynamic difficulties for sensor innovation. In medical services, there is a developing interest in wearable sensors that screen essential signs and give continuous well-being experiences. The car area requires sensors with elevated accuracy for innovative driver help frameworks and independent vehicles. Natural checking requires sensors equipped for distinguishing and examining a more extensive scope of poisons and environment-related factors. As businesses become more interconnected and dependent on information-driven independent direction, sensors should develop to successfully fulfill these arising needs. State-of-the-art sensor advance. Most recent sensor advances. Internet of Things IoT sensors. The coming of the Web of Things has introduced another period of sensor innovation. IoT sensors are interconnected gadgets that assemble and send information across networks, empowering consistent correspondence among gadgets and frameworks. These sensors track down applications in shrewd homes, modern robotization, and metropolitan framework. Wearable sensors. Wearable sensors have acquired boundless ubiquity for their job in private well-being observing and wellness following. These gadgets, frequently coordinated into smartwatches and wellness groups, can quantify pulse, movement levels, rest examples, and that is just the beginning. High-level imaging sensors. Advances in imaging sensor innovation have prompted the improvement of high-goal cameras and refined imaging frameworks. The joining of AI, artificial intelligence calculations upgrades picture handling capacities, empowering applications like facial acknowledgement, object location, and increased reality, natural and biometric sensors. Ecological sensors assume a basic part in observing air and water quality, weather patterns, and in general ecological well-being. Biometric sensors, then again, catch and investigate physiological or conduct attributes for distinguishing proof purposes. Reconciliation of artificial intelligence and sensor innovation. Harmonious connection among artificial intelligence and sensors. The collaboration between artificial intelligence and sensor innovation has introduced another time of clever detecting frameworks. Sensors gather tremendous measures of crude information from the climate, and artificial intelligence calculations process and dissect this information to determine significant experiences. Utilization of artificial intelligence in upgrading sensor capacities. Artificial intelligence calculations upgrade picture and example acknowledgement capacities in imaging sensors. This is apparent in applications like facial acknowledgement, object discovery, and clinical picture examination. The mix of artificial intelligence and imaging sensors empowers more exact and productive ID of items and examples. Prescient support in modern sensors. Artificial intelligence is applied to information from modern sensors to anticipate hardware disappointments before they happen. Well-being observing with wearable sensors. wearable sensors benefit from artificial intelligence in well-being checking applications. Independent vehicles and sensor combination, artificial intelligence assumes an essential part in the coordination of information from different sensors in independent vehicles. Sensor combination, where information from cameras, LiDAR, radar, and different sensors are joined, is worked with by artificial intelligence calculations to make a thorough and precise comprehension of the vehicle's environmental factors, prospects, and expected progressions mental sensors. The reconciliation of artificial intelligence could prompt the improvement of mental sensors equipped for learning and adjusting to evolving conditions. Edge registering for continuous examination, future progressions might see a shift towards more confined handling of sensor information through edge processing. This empowers continuous investigation, lessening the requirement for broad information move and upgrading the responsiveness of simulated intelligence-fueled sensor frameworks. Feeling and setting acknowledgement, artificial intelligence calculations could be additionally refined too. Perceive feelings and context-oriented signs from sensor information. This has applications in human PC communication, customized administrations, and the advancement of compassionate innovation that answers clients' personal states, energy-effective artificial intelligence sensor frameworks. Exploration is continuous to foster energy-proficient simulated intelligence calculations and sensor frameworks, urgent for applications in remote and asset-obliged conditions. This could prompt the making of practical and independent detecting arrangements with negligible natural effect. The combination of simulated intelligence and sensor innovation makes the way for many conceivable outcomes, from improving existing applications to empowering new use cases. As these advancements keep on developing, the harmonious connection among artificial intelligence and sensors will assume an essential part in forming the fate of clever detecting frameworks, scaling down and energy productivity pattern towards more modest, more productive sensors. The determined drive toward scaling down has turned into a characterizing pattern in sensor innovation. More modest sensors offer a few benefits, including expanded transportability, further developed joining into different gadgets, and improved openness in difficult-to-arrive-at conditions. Microelectromation systems MEMS innovation plays had a critical impact in this pattern. Empowering the creation of sensors on a microscale, the push for scaling down is driven by the interest for more conservative and subtle sensor arrangements without compromising execution. Headways in energy reaping for maintainable sensor activity, the mission for economical and independent sensor activity has prompted huge progressions in energy gathering advancements. Conventional battery-controlled sensors face difficulties connected with limited battery duration and natural effect. Energy-gathering techniques, for example, sun-oriented, motor, and nuclear power collecting, mean to resolve these issues by empowering sensors to create and store their own power. Suggestions for wearable innovation and IT gadgets. Scaling down and energy effectiveness have significant ramifications for wearable sensors. More modest, lightweight sensors are more agreeable for clients. Working with the consistent mix of wearable innovation into regular daily existence, improved energy effectiveness guarantees delayed utilization without incessant re-energizing. Making wearables more common sense and easier to use. Internet of Things IT gadgets. The pattern toward more modest sensors line up with the necessities of IT gadgets, where space and energy contemplations are essential. Reduced sensors can be consistently incorporated into a horde of IT applications. Going from savvy home gadgets to modern observing frameworks, well-being checking, and implantable gadgets. Scaled-down sensors find applications in well-being observing gadgets and, surprisingly, implantable clinical gadgets. The diminished size considers less obtrusive executions, while energy proficiency guarantees that implantable sensors can work for expanded periods inside the human body without successive substitutions. Ecological observing organizations. In natural checking, the arrangement of more modest, energy-productive sensors works with the formation of broad sensor organizations. These organizations can cover huge topographical regions, giving continuous information on environment, contamination, and other natural boundaries. The blend of scaling down and energy productivity in sensor innovation is reshaping the scene of wearable innovation, AI gadgets, and different applications requiring subtle and supportable detecting arrangements. As headways proceed, we can expect much more minimal and energy productive sensors that will open additional opportunities for observing and connecting with our general surroundings. Next is industry-explicit advancements. 1. Healthcare remodeling patients observation. Patient observing. The medical services industry has seen a change in perspective in quiet checking with the coordination of innovative sensor innovations. Wearable well-being sensors. Wearable sensors persistently screen crucial signs, for example, pulse, circulatory strain, and oxygen levels. Patients can wear these gadgets, furnishing medical services experts with constant information for more proactive and customized care. Implantable sensors. Implantable sensors offer a more profound degree of observing for patients with constant circumstances. These sensors can give continuous information on glucose levels, prescription adherence, and other basic measurements, considering convenient mediations and changes in accordance with treatment plans. Distant patient checking frameworks. Sensor networks empower the production of far-off persistent observing frameworks, permitting medical services suppliers to follow patients' well-being progressively, particularly for those with constant ailments. This approach improves patient commitment and lessens the requirement for successive emergency clinic visits. 2. Automobiles. Progressions in well-being and independent driving. The car business is going through a progressive change, driven by sensor advancements that upgrade security and prepare for independent driving. Advanced driver assist systems ADAS. Sensors like cameras, radar, and LiDAR add to the improvement of ADAS, giving elements like path-keeping help, programmed crisis slowing down, and versatile voyage control. These frameworks upgrade vehicle security and decrease mishaps, aid our innovation for independent vehicles. Light recognition and running LiDAR sensors assume a critical part in independent vehicle routes. These sensors make itemized 3D guides of the environmental factors, permitting vehicles to see and answer their current circumstance, even in perplexing and dynamic situations. Vehicle-to-everything V2X correspondence. Sensor-based correspondence frameworks empower vehicles to speak with one another V2V and with Foundation V2I. This availability upgrades traffic on board, lessens blockage, and further develops street security. 3. Ecological checking tending to environmental change difficulties. Sensors are essential in observing and relieving natural difficulties, adding to endeavors pointed toward tending to environmental change. Air quality sensors. Sent in metropolitan regions, air quality sensors screen poisons like particulate matter, nitrogen dioxide, and ozone. This information illuminates general well-being drives and works with administrative measures to further develop air quality. Sea and water quality sensors. Sensors in amphibian conditions screen water quality boundaries, including temperature, saltiness, and contamination levels. These sensors help in the preservation of marine environments and the assurance of water assets. Environment and climate sensors. High-level environment sensors add to environment research by gathering information on temperature, dampness, and barometrical circumstances. This data is significant for understanding environment designs, anticipating outrageous climate occasions, and planning procedures for environment versatility. Industry-explicit developments feature the assorted uses of sensor innovation, exhibiting its extraordinary effect across medical services, auto, and natural areas. As these developments keep on advancing, they add to more secure, more effective, and supportable practices in different enterprises. Next, joint effort and interdisciplinary methodology. Sifting of joint effort among scientists and businesses. The unique scene of sensor innovation requires a cooperative environment where specialists and ventures work connected at the hip to drive development, cooperation cultivates a trade of ability, assets, and viewpoints, speeding up the turn of events and execution of state-of-the-art sensor advancements. Speed up advancement. Joint endeavors among the scholarly community and businesses bring about accelerated development cycles. Scientists bring hypothetical information and novel ideas, while enterprises give pragmatic experiences and the means for enormous scope sending. Certifiable applications. Coordinated effort guarantees that sensor advances are created in view of true applications. Ventures carry important bits of knowledge into the difficulties and prerequisites of explicit areas, directing specialists to foster arrangements that are mechanically exceptional as well as functional and relevant. Market-driven arrangements. The cooperation among scientists and businesses makes a collaboration that produces market-driven arrangements. By adjusting exploration to industry needs, the advancement of sensor innovations turns out to be more receptive to advertise requests and cultural difficulties. Interdisciplinary endeavors to drive development. The interdisciplinary idea of sensor innovation requests cooperative endeavors that rise above conventional disciplinary limits. Interdisciplinary methodologies unite specialists from different fields, cultivating a comprehensive comprehension that is fundamental for leading-edge developments, physical science and materials science. Joint effort among physicists and materials researchers is critical for creating sensors with improved responsiveness and accuracy. Understanding the properties of materials at the nuclear level considers the plan of sensors that can work in outrageous circumstances or identify unobtrusive changes in the climate, designing and software engineering. The cooperation among architects and PC researchers is fundamental for the joining of sensors with information handling and examination calculations. This cooperative energy brings about insightful detecting frameworks able to do ongoing navigation and transformation, medical services, and information science. Interdisciplinary cooperation between medical services experts and information researchers drives developments in wearable sensors and well-being checking advancements. This cooperation empowers improvement of prescient models and customized medical services arrangements due to constant sensor information. Now, let us touch contextual analyses exhibiting fruitful joint efforts. 1. Savvy urban areas drives coordinated efforts between civil specialists, metropolitan organizers, and innovation organizations have prompted the execution of brilliant city drives. Sensor networks in these urban areas screen traffic designs, streamline energy utilization, and improve public well-being, exhibiting the force of interdisciplinary coordinated effort. 2. Biomedical sensor developments. Organizations between clinical scientists, designers, and biotechnologists have brought about forward leaps in biomedical sensors. Contextual analyses feature the fruitful improvement of implantable sensors for observing persistent circumstances, and the joining of sensor advances in symptomatic apparatuses. 3. Car industry headways. The auto business represents effective cooperation between auto engineers, PC researchers, and sensor producers, high-level driver help frameworks ADAs, and independent driving advancements are results of interdisciplinary endeavors that focus on well-being and development. Coming up is moral contemplations in sensor innovation. 1. Security concerns and information insurance. As sensor innovation turns out to be more inescapable, the assortment and usage of individual information raise critical protection concerns. Addressing these worries is fundamental to guarantee that innovative progressions do not think twice about protection privileges. 2. Dependable utilization of sensor innovation in reconnaissance. The utilization of sensors in observation applications, whether in broad daylight spaces or confidential settings, requires moral contemplations to offset security needs with individual protection and common freedoms. Straightforwardness in observation projects, legitimate and moral structures, and predisposition and separation alleviation is needed. 3. Tending to possible predispositions in sensor information. Inclinations in sensor information can emerge from various sources, including the plan of sensors, the information assortment process, and the calculations utilized for information examination. Distinguishing and tending to these inclinations is urgent for guaranteeing fair and impartial results. For energizing prospects and potential major advantages, the eventual fate of sensor innovation holds invigorating conceivable outcomes and huge advantages. Neuromorphic sensors roused by the human cerebrum could upset discernment, empowering sensors to deal with data in manners that impersonate organic frameworks. Self-fueled sensors, progressions in energy reaping, and self-controlled sensor advancements could prompt sensors that are energy independent, killing the requirement for outside power sources. To conclude, innovative and collaborative transformation in sensor technology is ongoing. By embracing the valuable open doors and difficulties that lie ahead, we can open additional opportunities, improve personal satisfaction, and add to a mechanically progressed and morally cognizant society. The eventual fate of sensor innovation is both energizing and promising, and it welcomes all partners to partake in. Molding the course of this groundbreaking excursion effectively, here we come to end this discussion. Thank you for joining us on this enlightening journey. If you found value in this vlog, do not forget to like, subscribe, and share with your friends and family. Until next time, take care and stay well.